All the girls get down. Get up.
Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard. Earth's gravitational pull decreases as we go further away, but not as quickly as most people think. And in this problem, we are calculating that at what distance above the surface of the Earth, so we're looking at altitude, is the acceleration to the Earth 0.98, which is 10th from that of the value on the surface. We'll begin to solve this based on what we know about gravitation. So Fg equals g times m, mass of any object, then mass of the Earth, divided by the radius from the center of the Earth. And we use our analogy from Newton's second law, which says sum of net forces is mass times acceleration. So if we reorganize this, so m times g me divided by r squared, then here we have the acceleration due to gravity. And we know that that value is 0.98 at the distance that we are trying to find out. So we have A equals g me divided by r squared. And from here, r would be just square root of g me divided by a. Now, the problem is that we don't know the gravitational constant or the mass of the Earth. That is the setup of this problem. So we only have to rely on the piece of knowledge that it's 9.8 on the surface of the Earth. So in this case, the acceleration a, we know its value on the surface of the Earth. That's g. So g is g times me. And now the distance from the center of the Earth to the surface is just the radius of Earth squared. And hence we get value for g times me, which is g times re squared. And we can plug that one in here to get square root of g re squared, replacing the gme divided by a. And re, of course, comes out from the square root, so we have square root of g over a. That's going to be our radius. So now if you put the numbers, radius of Earth, about the mean radius about 6,400 kilometers, and g was 9.81 meters per second squared, and at this other distance, it's only 10th of that 0.98, and we get radius about 20.2 times 10 to the 3 kilometers, so about 20,000 kilometers. But we have to be careful. So this is just the rate or the distance from the center of the Earth, right here, and we want to know the altitude, h. So h is then the radius we calculate minus the radius of Earth. So about 20,200 kilometers minus radius of the Earth, we get about 13,800 kilometers. So we have to go about the distance of 2 Earth radii to decrease the value to 1/10 from the acceleration on the surface. So the altitude where most of let's say, the International Space Station, for example, operates about 400 kilometers altitude, the acceleration of gravity is pretty close to the value of that on the surface.
Oh my dog, get up.